Welcome back to my channel. I'm Brian Kafke, and in today's video, we're going to be talking about the technology you need to learn. Before I jump in, anyone out there who's so inclined, please consider supporting me on Patreon, where you get access to special content, direct access to me, and more. I want to teach you how to fish, not just give you a fish for a day. So rather than just dump a lot of different techno goop on you and give you all these different new technologies, I want to walk through how you can discern what technology you need to focus on. So we'll talk about the problem and identifying potential options to solve problems, evaluating a technology in that regard, and I'm going to walk through some specific examples of how to do that. Then I'm going to talk about some assumptions that we need to bear in mind as we go through this. So my preliminary thoughts: ignore the hype. It's just sales. That's all it is. You hear this and you hear that, and somebody's promoting this. And of course, nowadays, where what you get in your feeds, wherever it is going to be dependent on what types of things you show an interest in or who you connected to on LinkedIn. It's going to be very distorted. It's all just a bunch of hype, and it's not something you want to pay attention to. You need to get past the hype to the reality. Focus on core technologies. What do you mean? What do you mean core technologies, Brian? What I mean is, if you're a data engineer or a data architect, there's some basic core technologies that you will use regardless of anything else. And then there's these kind of ancillary technologies. And I would put things like Airflow, Dask, and some of these other technologies as more ancillary. Core technologies would be things like basic languages like Python and SQL, as well as things like Apache Spark or Databricks, Snowflake, Synapse, etc. Those would be core technologies, assuming you use them a lot. They're the thing that you build your solutions around. So the question is, when you're looking at a technology, is it a solution or is it a solution still looking for a problem to solve? Way back, as an example, OS2 came out, and that was IBM's next generation. This is way back, right? IBM's next generation graphical user interface for DOS-based computers. Microsoft wrote it, but then Microsoft also wrote Windows. And we've all heard of Windows. You may not have heard of OS2 because OS2 was probably more of a solution looking for a problem to solve. In point of fact, it was way ahead of its time and required too much computer power to run it. So Microsoft wrote Windows as a solution to the immediate problem, which is giving people a nice graphical user interface that could run on existing computer hardware. That's the kind of thing I'm talking about. Pick the technology to solve a specific problem. Don't just look out there and say, oh, that looks cool. That's got a nice logo to go with it. Figure out what is your problem to solve. If you don't have a problem to solve, my advice is don't go down different rat holes trying to find problems to solve that you think you may encounter someday. I've done that and it usually doesn't pan out that way. But if you're on a project and you're using something and say, wow, we really need a good ETL tool, or we really need a way to do workflows, then that's when you say, we have a problem to solve and we're going to have to find a technology to do it. Once you have the problem you need to solve, then you need to figure out what exactly do you need the service to do to solve the problem. I like to use analogies. So I'll say, for instance, you got to buy a car. Well, you know you need a car, but what exactly do you need the car to do? I need it to be able to drive me from point A to point B. Probably not driving, we'll say, too far. I don't have a big, 10 people in my family to move around. Maybe it's just me and one other person. And those are the things you need to look at. What do I really need? Because if I don't define that, then a tractor trailer with 18 wheels would satisfy me just as easily as a Toyota Prius. But when I start to nail down the exact requirements, it's easy to figure out what fits. Then I need to take a look around and say, what are the services that will meet my needs? Now, in the case of a car, once I know that I really need a small car that's gas efficient, gets me to sort of short distances, then I'm in pretty good shape to figure out what I need, and I don't need to look at everything out there. In the same way, when you have a technical problem, let's say you need an ETL tool, then you don't need to be looking at operating systems or web development tools, etc. You're going to be focused on specific things that will solve the problem in ETL. And you need to know also how big a scale are you looking at, right? So some ETL tools will work for big data and some won't. So those are the kind of things you need to sort of consider when you're looking at what solutions fit it. Select a few solutions, 2 or 3, that may meet your needs. Then you need to dig down into each one and evaluate whether or not it is a good solution. Okay, how do I evaluate a given solution, Brian? Glad you asked. I start with read the docs. I go to whatever documentation is around, and hopefully there is documentation, or we probably have a good solution to eliminate from our list, but go to read the docs online, get a feel for the tool, look at how it works. Does it make sense? Can I make sense of what it's saying and say, okay, I could follow that. I think I could do this. I'm not actually going to try anything just yet. I just want to see how it looks. Then I need to look and say, okay, looks like it might do the job. How is the adoption and support of this tool? I look at things like, what was the last release? Now, this is particularly critical when you're looking at open source services, right? Apache Airflow, Apache Beam, whatever it is. These are open source, which means they rely on the generosity of developers out there to keep maintaining and adding features to it. Well, things get popular and very trendy for a while, and they get lots of support. They also can fall out of favor, and suddenly nobody wants to work on it. That's an old has-been service. If you are looking at a tool, you might be falling into that. You're looking at a blog from 5 years ago that says, this is great, this is awesome. And then you look at the last release, it's like, oh yeah, it was last maintained 5, 6 years ago. So that's not good. Goal here is to avoid adopting an orphaned tool. So you don't want to adopt something that doesn't look like it has a future. One way to tell if something is popular is do a search on YouTube, because if you look at something like Python, for instance, you'll see there are millions of views and many videos all around Python, which to me is a good indication that it's pretty widely used and pretty widely adopted. Another way is just do a web search and look around and see what technologies are being used. The read the docs for a given service may tell you major companies, whether it's IBM or Microsoft or Google, that use a particular service. That's a good sign. And those are the things you need to look at. The Gartner reports can be somewhat helpful there. But your goal is to just get a sense of, does this product have a solid foundation, and will it be in existence a few years from now? You need to estimate the cost, because this is something that rookies in the field of data engineering or programming, whatever, often overlook. They say, this is great, it does what I want, I'm happy. But they're not considering the bigger long-term costs. Is it good for the organization? How many people does it take to maintain? How high do the skill sets need to be? How difficult is it to code and maintain software using the tool, but also what's the cost of installing and maintaining the environment for the tool? If I can't get a simple hello world test running on a tool, that's kind of a red flag for me. A lot of things with Python, for instance, I can just do like a pip install, like Dask, and I'm up and running, at least to do a very simple test. Other services, you find it's a lot of work just to get to the point of doing the most simple hello world type of example. Now, if I get past that hello world test, then I want to do a little more digging in before I decide this is a good option. The devil's in the details, and that's what you need to find out. Trust your instincts. There's this fable about an emperor who loves to dress in all these fancy clothes, and finally they don't know what to tell him to wear anymore. So when he's not wearing any clothes, his servants tell him, you look magnificent wearing nothing. And everybody's clapping for this emperor, and everybody's telling him a lie, which is, he looks great and those clothes are amazing, until a child just looks and says, I don't see any clothes. And then everyone doesn't know what to do. They kind of freak out on the fact that this was said, the truth, but they accept and adopt what the kid said was right. The important thing is, it's okay to be the one that says the emperor has no clothes. Bear in mind, when you do that, though, other people may attack you for saying something so blunt. But you need to be able to do that. If you're an architect, if you want to be one of the senior level people advising your company on what they should do, you have to be critical and you have to trust your instincts. Let's take a little deeper dive into how do we evaluate a technology once we've gotten through those early steps. Ease of installation and environment maintenance is a crucial piece. I've been doing a lot around Apache Airflow lately, and my biggest concern about it is this item. It is not easy to install, and it does require environment maintenance. Most people's answer is just use Docker, but Docker may not be a good solution in every use case. Beyond that is also configurability, scale, and ease. What I mean here is, can this tool scale to handle larger volumes? And I'm thinking of specific things around data, right? Like ETL work, or maybe it's a job workflow scheduler. Can it handle thousands? Can it handle millions of tasks? Can it handle trillions of tasks? Most often when you scale something up, it means you're going to have to change the underlying platform. So how easy is that to do? If you have to take it and move it from, say, a single machine to Kubernetes, that's probably not trivial, but the service itself may allow you to do that more easily, depending on how it exposes its configuration options. Kind of reiterating the hello world case and maybe a few more simple cases, is it easy to learn and use this particular service? Now that has to be tempered by how sophisticated is the service. If you're trying to do something like an ETL tool, there's going to be a fair amount of work to learn before you can use that. So that's expected. If it's a no-code solution, then hopefully it's less work to learn. Then you get into the more complex cases. The simple use cases are great as a starting point, but when you actually use it in the real world, you're going to get into more complicated cases, and you need to make sure it will do what you need. You should also, at this point, try specific things that fit your requirements. For instance, maybe you need to read from a SQL Server database. Maybe you need to write to a data lake. Those are things you should try out. Don't assume that you can do these things because you could really end up for a nasty surprise. Beyond the actual environment, what about the applications you develop with the tool? So for example, Azure Data Factory. You can write pipelines and it's great and it does all this, but how easy is it to deploy those pipelines you create? Same thing with Databricks or many other tools. When you write things, how easy is it to write the application? But just as important, how easy is it for you to deploy the application and then maintain it? In other words, redeployments for modifications over time. What we're looking for is an optimal solution, not just a solution. This is a big mistake. On my video about Airflow, where I said don't use Airflow, I got a lot of criticisms around this idea because they're like, it works great, I like it. But they were missing my real point, which is, yeah, it can work. I could drive an 18-wheeler 5 miles every day to get to work, but it's not a good solution. It's not the optimal. And that's what we're really looking for as a data architect. Now let me walk through an example. Let's take a look at Databricks. This is something I've promoted a lot. I've gone through the evaluation long time ago. And so it's pretty easy. Obviously, I'm going to be pretty positive on it, but I want to show you why I think it's great. First of all, I started with read the docs like I recommended. And I found when I looked at it, I said, wow, this is actually pretty easy to use, makes sense. It's all works on the cloud, so I can do all kinds of great things. So I found it pretty intuitive right off the bat. Now, mind you, Databricks is not a small service. It's an ecosystem of many things. Not going to be really quick to get up to speed with it and use it, but given what it does, it's actually very easy to use and intuitive. What about popularity and supportability? Databricks is widely adopted, as is its underlying foundation, Apache Spark. No problem there. And both have frequent releases. Databricks I like in particular because there's the corporation Databricks, and they are commercial, and they support its product and have frequent releases and keep adding more and more things to it. But you also get to take advantage of the open source community because Apache Spark is what's under the covers. So it's kind of a win-win. What about cost? Since Databricks only runs on the cloud, which is Azure, AWS, and GCP, then it's really a matter of how cheap you want to be. I've been doing all kinds of training. I wrote a book using Databricks, and I was able to keep everything low scale and very inexpensive. But if you need heavy duty resources, you need to process, petabytes of data, then you'll pay more, but you're scaling as you go. So it's really up to you how much you want to spend, but the cost can be very cheap. How about trying it out with a hello world type of test? It's very easy to do that, but you do have to learn a little bit about Databricks in order to do that because it is, as I said, a pretty complex ecosystem. Let's look a little deeper at this. Ease of installation and environment maintenance. It's very easy to set up Databricks because it's leveraging platform as a service as well as software as a service, right? PaaS and SaaS, they're very popular. So there's where it's super easy to maintain. And since it's implemented as services in the cloud, you really don't have any maintenance to worry about. As far as configurability, scale, and ease, I think it's excellent because you can scale your clusters to make them dynamically scale up and down with many different settings. And you can use SQL endpoints that will manage clusters of clusters, essentially, to scale out your clusters. So there's a lot of options there. And there's all kinds of other features you can use that will also allow you to scale. As far as getting, again, into how easy is it to overall learn to do simple things with Databricks, I'd say it's moderate. It's easy to use if you understand the underlying technologies. But there is a little ramping up because it's a complete ecosystem. And again, also for the complex use case. I would say that once you get the basics, though, advancing to more and more complex use cases gets easier. And ease of maintenance and deployment, I would say is good. The only thing with Databricks that I find not perfect is that when you're in one workspace, that tends to be an environment. So you've got this team collaboration space, we call it Databricks Workspace, and that could be your development area. But then you also have a QA and a production. It's not seamless to move things between those three environments. So you do have to do some defining and figuring out how you want to do that. There's nothing really simple that you can just point and click in Databricks that will automate that process. What about alternatives? What else could we use other than Databricks? It's important to consider because There's always other options. Well, we could just go with open source Apache Spark. We could use Apache Hadoop MapReduce. I consider that to be a legacy tool. You could go with Snowflake if it meets your requirements better. And there's also cloud-specific options, right? Like BigQuery and Azure Synapse and on and on. And if you're really a Python shop, especially if you tend to be more on premises, then Python Dask, which is its Python library and more, that will scale out. That's a good option as well, potentially. Now I'm going to contrast this with another evaluation, kind of walking through my steps again. But before I do, I want to give you a little background in case you haven't seen my videos on Apache Airflow. Now, I like Airflow. It does a lot of great things. It is not a lightweight, simple thing to plug and go. You got to do a little work here. So let me talk about the moving parts. We have a metadata database service, and that needs to be running in the background. It has to be set up and installed. And that supports different database backends, SQLite being the default. We have a scheduler service, and that can be integrated with an executor, which makes it a little bit easier. But as soon as you want to break out that executor to run separately, then you're going to have to scale up, and it gets more complex. So of course, if you scale out to, say, Kubernetes, you now have quite a bit of compute to consider. You also have to have some sort of storage where you put your DAG definitions, which is your workflow definitions. And that's based on a Python library, but that Python library has many, many dependencies on other Python libraries, and that adds to some of the complexity. You also have a web server service to support a UI into Apache Airflow itself. So again, there's a lot going on here. Yes, it's a lot of features. It's very powerful, very cool, but these are things you need to consider. So let's evaluate Airflow. When I went through, I read the docs, and overall I kind of liked it at first, but I did find it was complex. It was not intuitive and simple to start off with. Moreover, I found the docs were misleading and incomplete. What was misleading, Brian? Well, first of all, they don't state outright that you can't run Airflow on Windows. And I work in a Windows environment. That's what I use in my machine. That's my client. So that was important to know because getting up and running with my Hello World is a lot easier if I can run it on Windows. And there are other cases. It doesn't talk a lot about how to install and get it running. It gives some basic ideas about how to use Airflow. I ended up going to books and things that were a little more extensive to understand that better. Nobody seems to like talking about configuring Airflow in different environments. I couldn't find a lot out there on that. Popularity and supportability. Airflow is pretty popular overall, at least if you do YouTube searches, etc. You'll get a lot of hits. You can see quite a few people do seem to like it, and it does get used. When I look at releases, I can see that about every a month and a half to 2 months, there's a release. So that's not nearly as frequent as, say, something like Databricks. Now, mind you, I'm not comparing these to each other so much as a reference point. Airflow is not something that is getting everyday updates, etc. It's like every couple of months. Now, Airflow is strictly an open source on-premises service. Okay, you can install it and use it. It's meant for on-premises. It is maintained solely by the generosity of the developers who choose to volunteer their time for it. And like any open source technology, you have to bear in mind they could just choose not to support it at some point. If you keep in mind that diagram I just showed you, at minimum, there's a few virtual machines required to get that thing up and running. If you want to scale it up, it's going to be a lot more machines. You're running in the cloud environment using virtual machines, or perhaps you found a service that will wrapper it for you in some sort of a PaaS offering. There's still a lot of compute costs that are going to add up in the cloud. Or on premise, you're going to have to manage all that. And it's not a trivial environment to maintain. Let's assume you have 3 virtual machines running on premises just to maintain your Airflow environment. That takes people to maintain it, to install patches, install releases, and there are things that could go wrong that will break. To try just a simple Hello World test, I was very frustrated. I had to step back because I'm used to being able to do something like pip install, Python library, I'm good to go. And as you can tell, again, from that environment, it's a lot more than that. Ease of installation and environment maintenance, it's complex, and there's no PaaS or SaaS offering for this generally. I did find one available on Azure that was a company called Astronomer, but the beginning starting point was really costly. Ultimately, it's just wrappering the Airflow environment. And I believe AWS and Google do have some PaaS offering that they wrapper around this, but I haven't had a chance to look at that. What about configurability and scale and ease? I would say it's excellent scale, but ease, it's complicated to do that scale. As far as learning and doing a simple use case or a complex one, it's difficult for either one. And of course, maintenance and deployment, pretty complicated, I would say. There's pieces to worry about, etc. What are the alternatives to this, Brian? Do we have any options? Okay, well, let's consider this. And again, this isn't meant to criticize or even evaluate, in this particular case, Airflow. meant to walk you through how we look at technologies. So cron is a good option. It's not a competitor to Airflow. It's like a really simple, lightweight alternative. If all you need to do is run a Python script, then just use cron. You could use Python Luigi. Luigi is very similar to Airflow, but it seems simpler and lighter weight. I've only done a cursory look so far. I hope to do a video on Luigi in a future date, but that looks to me like a simpler alternative. If you're looking for ETL, which often Airflow is promoted as, it's an ETL tool. Move and transform your data with Airflow. It actually isn't. It's a workflow orchestration engine. So if you really look for ETL, you could look at something like Apache NiFi. If you are looking for workflow orchestration and you happen to be more of a Windows side person, then you could use PowerShell workflow runbooks. Now you can run PowerShell workflows on your client machines, on VMs, or you can run them in Azure Automation if you're using Azure. You also have cloud-specific options. Again, depending on whether you interpret Airflow as being a workflow engine, which is really what it is, or an ETL tool. As a workflow engine, I mentioned PowerShell. You could also use something like Azure Functions if you're on Azure, or if you're looking more for an ETL tool, then you could use things like Azure Data Factory. First assumption that you need to keep looking at as you are evaluating a given tool is it meeting your requirements? You also need to consider your organization's strategy and goals. If you pick something like, we'll say Python Dask, you said, this is the thing, I want to use Python Dask, yet your organization's strategy is to use Java. Java for everything. That's great. We're going to use Java. Well, using a Python library-based solution is probably not going to fly. Related, consider the technical skills of your team. If you're going to choose something, like let's say you're in a Python shop and you love it, and it's great, and you decide to implement tool that is completely based on the R programming language. Do you have people that can even write the code on that? Do you have people who are skilled enough to maintain an environment that works off, say, RStudio with R code? It's important you evaluate these things, and a lot of times I've noticed technical people just kind of gloss over these things. They just like it themselves, but they don't look at the bigger picture. There's also a bit of the crystal ball, reading the future. There's a highway of broken dreams out there of all kinds of cool services and tools that were hyped as being the next thing since sliced bread, and then they just kind of disappeared over time. Don't be that guy that puts that one in and says, let's go with it, and then a couple of years later, you're like, yeah, that didn't pan out so good. Who suggested that? Ryan did. So don't do that. So wrapping up, I talked about preliminary thoughts and how to fish. In other words, how to choose the right services, what you need. And this is a bit of a twist because I didn't just hand you technologies like everybody else does. Learn this, learn that, because it's great and I love it and I'm not going to tell you why. Instead, I'm saying don't just adopt things. Focus on your core skills. I've had people tell me, I know SQL. You don't know SQL. I've been doing it for many, many years and I'm still learning things all about SQL and how I can code better in it. And same with Python and on and on. So expand and get better at your core skills. Don't get too worried about all these ancillary services out there. But if you do need a solution for something, we talked about how to identify potential options and then evaluating the technology, looking at how it fits, look at how costly it is, look how easy it is to use. I walked through a couple of examples. One was Databricks and the other one was Apache Airflow, just to contrast, not to be too critical or positive, but just to show you how evaluations might differ. And then I walked through the assumptions, most importantly, that whatever you choose can support your requirements. And bear in mind, you might have requirements that is one thing today, like Airflow, for instance, works great as a batch tool, but it doesn't support streaming. So you have to be careful not to get caught up in those kinds of limitations that you don't think of until it's too late. That's it for this time. I want to thank you. Please like, share, subscribe, tell your friends about my channel. Until next time, I'm pulling for you. We're all in this together. Thank you.